go. Oh, no. This is the section 2.4 Pre-Calculus instructional YouTube video. And today we're talking about complex numbers. So the learning targets are to add, subtract, multiply, and divide complex numbers, ones that have imaginary parts, fun. And we're going to find some complex solutions to quadratic equations, once again, with imaginary parts. Oops, there we go. So first off, what is a complex number? A little background on this. So solving quadratics is a big part of applied mathematics, right? Like gravity works in like a quadratic manner. Acceleration is quadratic. So I mean, like if I toss this pen, right, it makes a little parabola in the air. So solving quadratics is just something that people do in applied math. So it'd be kind of lame if we could only solve equations where it's x squared equals 0 or x squared equals positive number. That like cuts the number of solutions in half. So mathematicians are like, well, there's all these crazy things happening where we have x squared equals negative number, and they seem to have these real like applications, but we don't have a number that we can square root. We can't square a negative and get like a number. So what they decide to do is they decide to just make one up. So basically any negative number, like if I have any negative number can be written as negative 1 times that number. It's like if I had negative 5, that's the same as negative 1 times 5. So basically if I want to square root a negative number, let's say I want to square root negative 25. What I can do is I can square root negative 1 and then square root 25. And mathematicians decided, well, if we want to square root negative numbers, all we got to do is be able to square root negative 1. Because we can square root positive numbers, and any negative number is negative 1 times a positive. So they came up with this wonderful new number. The square root of negative 1 is I. They just defined the square root of negative 1 as I. Just what it is. So these are imaginary numbers. So this is an imaginary number. Now, complex numbers are what you get when you combine real numbers with imaginary numbers. So they're written as a plus bi. That's the standard form to write a complex number, where a and b are real numbers. So a and b are real. Now every real number is just a complex number with 0 for its imaginary part. And every imaginary number is a complex number with 0 for its real part. So we have the real part, and then the imaginary part with the I, imaginary part. And one more thing, if I take I and I square it, it's going to be negative 1. So, because the square root of negative 1 is I, so if I square it, I get negative 1. All right, that's all about that's about all you need to know to get started with complex numbers. Now we're going to do a little bit of arithmetic with complex numbers. So we're going to do a little adding, subtracting to start it off. You've probably already done this, but it might be just a nice little refresher. Here we go. We have 3 plus 5i plus 10 minus 7i. We're going to do that one first. You can go ahead and write that down and give it a shot if you want. And then I'm going to do this. I'm going to put this one up. 4 minus 3i minus 7 plus i. All right, let's start with the addition problem. The addition problem, what we're going to do, all we basically do is we just combine like terms. We add the real parts together, we add the imaginary parts together. So I have 3 plus 10 is 13. I have 5i minus 7i is negative 2i. 13 minus 2i is our answer. That's it. Add the real parts, add the imaginary parts, boom, write your complex number. All right, next one we have subtractions. We're just going to subtract the real parts and subtract the complex parts. I am going to take it one step further and go 4 minus 3i, and I'm going to distribute this negative so I don't forget that I'm subtracting. So minus 7 minus I, and then we're just going to combine like terms. 4 minus 7, well that's negative 3. Negative 3 minus 1i, well that's minus 4i. So negative 3 minus 4i, that's it. Got it. Nothing else to do. What's up? That's adding, subtracting complex numbers. So basically you're just combining like terms. It's just the I is kind of like an X, just treated the same way. All right, let's talk about multiplying some complex numbers. Multiply. All right, we have negative 5 times 6 minus 8i. Do that one. We have 4 plus 3i, shake it, times 2 minus 6i. We're going to multiply both of these. Another thing, sorry. Complex numbers are wonderful because, just like real numbers, they're closed under addition, subtraction, multiplication, and division as long as we're not dividing by 0. What that means is if I add 2 complex numbers, I get another complex number. If I subtract 2 complex numbers, I get another complex number. If I multiply 2 complex numbers, I get another complex number. And if I divide, I get another complex number, as long as I'm not dividing by 0. So that's why we're doing this, right? All the stuff that we can do with real numbers, we can do with complex numbers. It's just a little bit more complex. All right, let's go ahead and do this. So here, this is multiplying 2 complex numbers. It's just the negative 5 doesn't have an imaginary part. Sorry, negative 5, you're real. So here we just distribute. We just go negative 5 times 6 is negative 30. Negative 5 times negative 8 is positive 40. And then I. So multiply the coefficients, and the I just stays as an I. That's it. That's all it is. Negative 30 plus 40i. Boom. All right. Here, this is a little bit different. So you know how to multiply something like this: x plus, or let's just, yeah. If I had x plus y times a plus b, right? We could draw a box. X plus y, a plus b, multiply, 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 multiply. That's all we're gonna do. You can either draw the box or you can FOIL. I like the box method, so I'm gonna draw my rectangle. I'll do some with the rectangle, some examples without. So here, 4 plus 3i times 2 minus 6i. 4 times 2 gives me 8. 2 times 3 gives me 6i, because I can't multiply the I, but just 6i. 4 times negative 20, or negative 6 is negative 24i. And then here, this is the interesting one. We have 3 times negative 6 is negative 18, but then I have an I times an I. And an I times an I doesn't leave the whole world blind. That's an I for an I. But an I times an I times I is I squared, which is negative 1. So I have negative 18 times negative 1, which is really positive 18. Ooh, that's the tricky part. That's really the only tricky part with these, is when you're multiplying I times I, it's negative 1. So really I have negative 1 times negative 18 to get this positive 18. All right, now what I'm going to do is I'm going to combine my like terms. 8 plus 18 is 26. And then negative 24i And 6i is going to give me negative 18i. And that's it. I hope I didn't goof. I did that all in my head with multiplying. We'll see. If I goofed, call me out, please. All right, so that is some multiplication. We're going to do a couple more multiplication problems, and we're going to move to division. Hooray! And remember, you can rewind this because it's a video. You can pause it. You can slow down how fast I'm talking. You can put subtitles on, right? Little closed captions. I think they're down here. You can change the language in the subcaptions if you want. Or subtitles, subcaptions. Who am I? All right. Let's go 9 minus 5i squared. And 4 plus 7i times 4 minus 7i. All right, I want you to try these two on your own, so go ahead and boop. Pause the video. Actually, it should be down here, I think. Pause the video. Maybe it's down here. I don't know. Pause the video. And sorry if you paused it the first time and then unpaused it and I kept telling you. Do these two, please. Go. Okay, and we're back. Here, 9 minus 5i squared is not 9 squared minus 5i squared. It's not that. What it is it's 9 minus 5i times 9 minus 5i. I'm going to do this one with the FOIL method. FOIL. First, outside, inside, last. So I'm going to go 9 times 9. 9 times 9 gives me 81. And then I'm going to go 9 times negative 5. That's negative 5i minus 45i. And then I got a negative 5i times 9. That's another minus 45i. And then I have, this is a different color here. It's getting a little messy. I apologize. The minus 5i times minus 5i. So negative 5 times negative 5 is 25. And then times I. So I've got negative 5i times negative 5i. It's going to be 25 times negative 1. Because negative 5 times negative 5 is 25. I times I is negative 1. So this gives me a minus 25. And now I combine like terms. I've got an 81 minus 25. Oh boy, that's going to give me 56. Yeah, 6, 11, yep. And then here, negative 45i minus 45i is going to give me 90, minus 90i. And that's it, that's the answer. All right. If you just squared both of these, you probably missed the minus 90i because you didn't have those in the middle. All right, let's look at these two, or this product. What's special? What do you notice about the numbers here? 4, 7i minus 7i. These are what we call complex conjugates. And conjugates keep showing up all the time in mathematics. We're trying to rationalize something, rationalize it in the sense of getting rid of square roots. And it comes up in chapter 5 when we're doing proofs with verifying trigonometric identity. So this idea of a conjugate comes up over and over again. And what happens when you have two things that are conjugates of each other, which is same number plus or minus same number when you're multiplying those are conjugates, where these are the same numbers but it's a plus, one's minus, is that middle term is going to cancel out every time. So let's just see this. Let's see it happen. I'm going to draw the box again. I like the box better. It's more organized. All right. So I got my 4 plus 7i. I got my 4 minus 7i. 4 times 4 is 16. 4 times 7 is 28i. 4 times negative 7 is negative 28i. Woohoo! Those are going to cancel. And then here I have negative 7 times 7, negative 49. I times I is negative 1. So really, it's a positive 49. And when I simplify this, when I put it all together, I'm going to get 16 plus 49, which is going to be 65. Now let's just take a little deep dive into the whole idea of a complex conjugate. If I have a plus bi, it's not that deep of a dive, times a minus bi. So where a and a are the same, b and b are the same, the only difference is a plus and a minus. We've got two complex numbers. These are complex conjugates of each other. If I multiply them, this is what's going to happen. A plus bi, a minus bi. A times a is a squared. A times b is ab, so I have abi here, abi. And then here, a times negative bi is negative abi, negative abi. And then here, I'm going to get a negative b squared. And then I times I is negative 1, which really is just going to be a b squared. So these two are going to cancel out because it's plus or minus the same number. And I get a squared plus b squared. So when you're multiplying two complex conjugates, here's a little shortcut. The middle term is always going to cancel out, and you're always going to get a squared plus b squared. Just like here, it was 16, 4 squared, plus 49, 7 squared. And guess what? That is a real number. It's still complex. It just has 0 as its imaginary part. It's like 65 plus 0i. We would never write 0i, we just write 65. It's still complex though. There's just 0 for the imaginary. Okay, let's move on to division. Hey. Division. Why do you wear glasses? Because they help with division. Woo! All right, let's do a quotient here. So we have 2 plus 3i divided by 4 minus 2i. What I want to do here, so with this, I can't split this fraction. I can't split the denominator. No matter what, there's going to be i's floating around in there. I could go like 2 over 4 minus 2i plus 3i over 4 minus 2i, but no thanks. And it doesn't really make sense to like try to conceptualize how to divide by by a complex number with an imaginary part. Like it makes sense to divide something by 3, you just cut it in 3 pieces, right? Like that sort of thing makes sense. Divide something by half is really just doubling it. So what we're going to do is we're going to try to make the divisor, the bottom number, a real number without changing the value of this quotient. And the way we do that is, you guessed it, using the complex conjugate. Maybe you didn't guess it. I don't know. I just want to say that. So we look at the denominator. The denominator here is 4 minus 2i. I want that to be a real number, so what I do is I multiply it by 4 plus 2i. Now I'm multiplying the denominator by 4 plus 2i, which is going to make the denominator a different value than what it was before. So I need to multiply the numerator by 4 plus 2i, because if I multiply by something divided by itself, anything divided by itself, even a complex number with a non-zero imaginary part, something divided by itself is just 1. So here I'm not changing the value of this quotient. I'm just making it look nicer and easier to think about. So the trick is multiply by the conjugate over the denominator divided by the conjugate of the denominator, right? It's 4 minus 2i, I multiply by 4 plus 2i. Now we have 2 multiplication problems to do. But this one's really easy. The conjugate is easy. Okay, but let's do it. All right. 2 times 4 is 8. 2 times 2 is 4i. 3 times 4 is 12i. And then 3 times 2 is 6, and I times I is negative 1, so it's minus 6. All right, and then 4 times 4 is 16. Here I'm going to get an 8i. Here I'm going to get a negative 8i. Those cancel like we expected. And then here I get a negative 2 times a 2 is negative 4. I times I is negative 1. Negative 1 times negative 4 is 4, so plus 4. And we could have used this shortcut to say 4 times 4 is 16, a squared, 16. B squared, 2 times 2 is 4, 16 and 4, right? All right, let's go ahead and combine some like terms here. We have 20 in the denominator. And then I have 8 minus 6 is 2. And I have 4 plus 12 is 16i. And I want to simplify this. I want this in standard form. Standard form is a plus bi, where a and b are real numbers. Each of them, they could be negative. It could be like negative 2 minus 5i. That would be fine. But separate. So anytime you have a fraction and you have one number in the denominator, you can split the denominator to 2 over 20 plus 16 over 20i. Because this is just working backwards adding fractions, right? If you add fractions, you need a common denominator. If I were to add this together, it'd be 2 plus 16i, all over 20. I'm just splitting it. I'm like factoring out that 1 over 20, but I'm keeping it on each term. So now I simplify. 2 over 20 is 1/10. That's my real part. That 1/10 is keeping it real. And then plus 16 and 20, 4 goes into both of those, so 4/5 I. And that's it. That's it. 1/10 plus 4/5 I. That's our answer. I hope it's right. I might have goofed. The ideas are all there though. All right, let's add a couple quotients. And that'll be it. That'll be it for the video. It was a nice quick one. Hopefully the homework will be fairly quick too. Once again, if you see a spot that I goofed, please let me know, call me out, so that I can make sure everybody else knows where I goofed too, if I goofed. All right, we're gonna add a couple quotients here. We've got 2i over, let's actually do this. This is a more complicated problem here. 3 plus 4i plus 3 over 4 minus 2i. Yeah, cool. Well, in order to add a couple of fractions or quotients, we need a common denominator. Well, what we could do is I could multiply this denominator by 3 plus 4i, and then top of like 3 plus 4i over 3 plus 4i. I could multiply this by 4 minus 2i and 4 minus 2i. But then I'd get these like complex numbers, crazy complex numbers in the denominator again. Like, there'd be more stuff going on. What I'm going to do is I'm going to basically find the quotient for each of these and then add the fractions. So I'm going to simplify each quotient first. So I'm going to multiply this by 3 minus 4i over 3 minus 4i. Because the complex conjugate of 3 plus 4i is 3 minus 4i. I'm going to multiply the 4 minus 2i by 4 plus 2i. And I'm going to see what I get. So I got 2i times 3. That's 6i. And then I have 2 times 4 is negative 8. There's a negative, sorry, negative 4 and 2 is negative 8. I times I makes it a plus 8. And then over, we're going to have 9 plus 16, 25. Yeah, 9, 16, 25, yep. And then plus whatever I get here. 3 times 4 is 12. And then 3 times 2 is 6, so plus 6i over 4 times 4, that's going to be 16, and right, that's 16. I'm going to get negative 8i, positive 8i, plus 4 over 20. Yeah, here we go. All right. So we got a couple options here. One, I could just straight up go for it and find a common denominator. I could do that. Or I could be a little bit more clever. I say, hey, look at the 12 plus 6i over 20. 12, 6, and 20 are all divisible by 2. Yeah. So I'm going to simplify this. I'm going to simplify. I know 12 over 20 is the same as 6 over 10. I know 6 over 20 is 3 over 10. In other words, I'm going to divide out a 2 from each of these. I'm going to factor a 2 out of the top, I'm going to factor a 2 out of the bottom and cancel it out. So basically it's like this. 2 times 6 plus 3i over 2 times 10 whoop, gives us 6i plus 8 over 25 plus 6 plus 3i over 10. Now, I can more easily find a common denominator. What do 10 and 25 both divide into? Or what's a common factor of them? Well, it would be 50, right? I need this to be 50, so I'm going to multiply by 2 over 2. I need this to be 50, so I'm going to multiply by 5 over 5. That gives me 12i plus 16 over 50. Plus 30 plus 15i over 50. Combine my like terms, because I got common denominator. 16 and 30 gives me 46. 15 and 12 give me 27. Yeah, plus 27i. It's all over 50. I want it in standard form, so I'm going to split it. Over 50, over 50. Simplify. 46 and 50. 2 divides into both of those. So that gives me 23 over 25 plus 27 and 50 are relatively prime. In other words, they don't have any numbers that divide into both of them other than 1. So we get 27 over 50 I for our answer there. And that's that. You could have just as easily made a common denominator of 100 on this step. So multiply this by 5 over 5. Multiply this by 4 over 4. And it would have worked just as well. It would have worked just fine. So this was just a little bit of fun for me. That's it. Hopefully it makes sense. I got office hours and all that. If you have any more questions, have a wonderful day. You rock. And double check. Yeah, that's it. Cool. See ya.